We are going to evaluate the integral from 0 to 1 natural log of x dx without using UV method. Anyone who took calculus can easily solve this problem using UV method. We are going to evaluate this integration without UV method using Feynman technique, also known as Leibniz rule, which is differentiating under the integral sign. Before we evaluate the integration, we have to guess a function. So let's do some calculation. So partial differentiation with respect to alpha of x to the power alpha is going to be x to the power alpha ln x. We can show that easily by some calculation. So partial alpha of x to the power alpha would be partial alpha of e to the power ln x to the power alpha. So this would be e to the power ln x to the power alpha times partial alpha natural log of x, which is just, so e and ln cancel each other and gives x to the power alpha. So partial alpha of alpha times ln x is just ln x. So we can see that for alpha is equal to 0, this term would give us the desired integrand. Let I of alpha integral from 0 to 1 x to the power alpha dx. I prime of alpha would be integral from 0 to 1 x to the power alpha ln x dx. So we can see that I prime of 0 is integral from 0 to 1 ln x dx, which is just our desired integration. So first evaluate I of alpha integral from 0 to 1 x to the power alpha dx. We can easily evaluate this integration x to the power alpha plus 1 over alpha plus 1 from x0 to 1, which is just 1 over alpha plus 1. I prime of alpha is minus 1 over alpha plus 1 square. I prime of 0 is equal to minus 1. So integral from 0 to 1 ln x dx is equal to minus 1.